Hi, when the new release of Meshlab came out, we received several alarmed messages by users because the Poisson reconstruction was not available anymore. Poisson reconstruction is very useful to have a triangulated surfaces starting especially from noisy point clouds, so lots of people are using it. But clearly we did not decide to remove the Poisson reconstruction, but we simply put a new implementation, a more recent implementation of this reconstruction, and you can find it in the remeshing, simplification, and reconstruction submenu as before. It's just the last one, and it's called Screened Poisson surface reconstruction. As usual, if you start writing Poisson, for example, or Screened in the search feature, you will have this. So if you choose the Screened Poisson surface reconstruction, this is essentially the implementation that was made available to the public of the paper that I invite you to cite if you are using this reconstruction a lot and you make publications out of that. And so this new version of Poisson is much more able to preserve the details in the final reconstruction. So especially when you have very big 3D models with very fine details, now you're really able to preserve all this detail. So the implementation is quite simple. There are, as usual, some parameters which are important. And there are also some small changes with respect to the previous version of Poisson in Meshlab. First of all, you see here that there is also the possibility to merge all the visible layers automatically before making the Poisson reconstruction. So in the previous version you had to be careful because the method was applied only on the current layer. So if you had several portions of an object which have been aligned, you had to remember to make the flattened visible layers and create a unique point cloud or unique geometry before starting the reconstruction. Now you can do that just by selecting this option. Then this parameter is the most important one. The reconstruction depth is very similar to the first two parameters of the previous version of Poisson, and essentially this is the maximum depth of the octree that is used to make the reconstruction. So in general, the idea is that the bigger is the better. So the higher this value, the more time will be needed for the reconstruction, the more detail will be preserved. As a rule of thumb, usually it's not worth putting a value which is bigger than 12, 13. Maybe 13 could be okay, but from 14 on, usually it's not possible to see any real change in the final result. So my suggestion usually, if the dataset is really not too big, you may start with 11 or 12 and see what is the result, and then if you really want to wait some more time, you can put a bigger value. So let's launch the reconstruction as it is with the other parameters. So while it's reconstructing, I will talk about the other options. So the other two numerical parameters are the minimum number of samples, which is a value that was available also before, and this essentially is a control on how smooth you would like to have your final surface. So if you have also a look at the help associated to this value, it tells you that any value between 1 and 5 is able to reconstruct the final model with a certain degree of detail, and it will try to preserve the detail as much as possible. If you're dealing with more noisy data, the suggestion is to put a higher value. So the higher this parameter, the more the final result will be smooth. This means that you may be able to remove the noise, but at the same time you may lose some detail. Really depends on your input data. And so this is a final result. Another important thing that can be seen is that the color attribute is automatically transferred to your reconstructed mesh. So you don't have to make the vertex attribute transfer anymore. And here is the reconstruction. and this is the basic geometry that is reconstructed. The Poisson reconstruction works more or less in the same way, so it will try to fill the missing part and possibly also to create a closed surface. And having a look at the triangulation, it may be easy to understand which are the parts which have been kind of invented or don't come from dense data like this one with this type of triangulation, to the part that really come from more dense data where you will find much more dense triangulation. So the third parameter is interpolation weight, is essentially a parameter that is strictly related to the capacity of this algorithm to really preserve the detail. Essentially, the idea is that if you put 0 here, the result that you will have will be the unscreened Poisson, so the previous version of Poisson. So if you want, if you really like the reconstruction of the previous filter in the previous release, just write 0 here, and you will have the outcome of the Poisson. What is important here is that while it's really able to reconstruct the detail which really in much better way, and it really gives impressive results, if you're dealing with noisy point clouds, or for example if you have small misalignments between two different like point clouds that you aligned, well, in this case it could happen that in the reconstructed surface you will have double surfaces or very bad topology. So if you're experiencing this and you cannot really fix the input data, then one way to try to have a continuous surface is like to reduce this interpolation weight parameters. Then there are two other options. One is the pricklian option, which essentially removes some reference vertices or vertices without normals. And the confidence flag is a way to make a reconstruction taking into account also the quality value. So if you saved any quality value in your initial point cloud, then it may be used also to make the reconstruction. It could be very useful if you have any notion about the quality of your input data. Actually, there are also other parameters that can be changed. You just can click on this small triangle. I'm not talking about them in detail, but if you click on the help button, as usually, you will have a lot of detail on this, so that you can maybe try to make things to try to have different results by playing with these parameters. So Poisson reconstruction is really powerful, quite easy to use, and it really takes the place of your previous Poisson, which much more capacity to preserve the details. So now if you really want to reconstruct a big object with fine details, you should be able to have your final result. Last two very important things are that first of all, the current implementation doesn't have the previous issue that you couldn't launch the Poisson reconstruction twice in the context of the same session. Now it's not a problem anymore, so you can launch the Poisson reconstruction as many times as you want, and nothing will crash. And the other important thing that also the handling of the memory is much better. This means that if you have enough hardware resources, you should be able to make the reconstruction also of very, very big surfaces, and you will have nice results. So it will take time, but it's much more stable than before. Thank you.